Hi everyone, I'm Dr. Bernice Kwong from the University of Southampton, and this video will show an example of how to do an event history analysis using the Harmonized Histories dataset. You can watch video 1 in this series to get a quick introduction to what the Harmonized Histories are, what kinds of data they contain, and how to access them. Due to privacy and data security, I cannot post any of the data, but I have posted as a work example all the code that I've used in this video. And you can also find in video 1 where to download the data set to use for your own research. So the harmonized histories are great for studying fertility events, and often researchers are interested in studying the event of the first birth, when a person would have their first biological child. So in this example, we will show how the transition to first birth can be analyzed using Stata. If you need a more detailed explanation of event history analysis in general, you can see the titles and NCRM resources that I've listed in the further reading section. But generally speaking, the first step of any event history analysis is, well, you need to figure out what your event of interest is. And in this case, it's the first birth, for our example. And then you need to decide when someone becomes at risk of experiencing that event. So the standard age that we tend to use for giving birth in demographic research is age 15 for women or females. The person then exits the risk set, which means they are no longer at risk when they either experience the event, so when they give birth, or when they are no longer at risk anymore. For example, for women, this could be when they turn 50 and are very unlikely to have a biological child, or when the observation period ends, which is the time of interview. So you need these crucial pieces of information to tell Stata, and then you do this using a Stata command called stset. So stset is the command you would use to declare to Stata, this is event history data. It tells Stata what the key variables are and their role in event history, or it's sometimes called survival analysis. So stset doesn't change the data, but it calculates and adds variables to the data set that are handy for event history analysis. So the structure of stset, so you type in the command first, and then you articulate what the variable is. So I've just called it time variable for our example, and that's either the time of event or the time of censoring. Censoring is the end of the observation period when an event doesn't occur. So this will be at the time of interview, because the respondent can only report what has happened in their life up till the moment that we ask them. They can't report what hasn't happened yet. So it'll either be the end of the interview or up to the interview date, or it will be when they turn 50, when they're no longer at risk for a live birth. The failure, so think more about survival analysis. A failure is the event of interest, and in this case, it's when somebody has that birth. So when the birth event equals 1 for versus zero events, and then the origin is when they become at risk. So in our example, our respondents become at risk of having a first birth from age 15. So these are the variables that are then calculated by Stata and added to the data set when you stset your data. So this variable underscore st indicates, will this record be used or dropped? A 1 indicates it'll be used, a 0 means it'll be dropped. Underscore D is, did the event happen? Did the event of interest happen? Did this record, this person, have a birth? And 1 is, again, yes, and 0 is no. Origin is the evaluated value of origin, or in our case, the year the subject turned 15. Underscore T is the analysis time. So how long did it take for either the event to happen or the person to leave the risk set? And then underscore T0 is the analysis time when the record begins. So for everyone in our sample, it's at age 15. So once you've done this, you can look at how an event, you can use the command stgraph. You've told Stata, this is survival data. And then you can plot a Kaplan-Meier curve, which shows the transition to that first event using the command stgraph. So on the y-axis, we have the proportion of people who have not experienced the event yet. And at the very beginning, 100% of your population have not experienced the event. But as time goes on, more and more people transition towards having experienced events. So they fail or they don't survive in the time being. So the proportion of the sample, yeah, so the proportion who have survived are on the y-axis. Analysis time in years in our case is on the x-axis. And remember, analysis time starts at age 15. So you would have to add, so 10 actually means 10 plus 15, which is 25. And in our case, about 50% of the sample, so over here, experience the event around here. So remember the event is having that first baby, about 18 years after being at risk. And because we started the clock at age 15, 15 plus 18 is about 33 years old. Okay, then you can plot the same curve by background characteristics and see what people's pathway towards the event of interest is according to their educational backgrounds. So here, as we would expect, people who have different levels of education tend to have their first children at different times. With the blue highly educated people waiting longer, they don't fall off that edge as quickly. They wait longer till around 34 to have their first baby. So about half of people, like around here. And then people who are less educated, so the green is the low educated people, they plummet off this cliff a little bit more quickly. And they start having their first children at a younger age, around 26, which, if you're familiar with the social pattern of first birth, that's pretty expected. And then you can plot the cumulative hazard of the event. So instead of thinking about these events as failures, we can think of them as hazards, which is basically the opposite of survival, but on a different scale, since hazards are calculated differently. So it's, instead of being bound from 0 to 1, like a proportion, which survival is, it can be greater than 1. But it tells the same story, that those with less education start having children earlier and have a higher hazard sooner. Okay, and then finally, you can use the command streg, which is a regression, ST regression, basically, to do a parametric analysis of the first birth event. So here we do a regression analysis, and because it uses streg, which is a command that's specifically geared towards event history and survival analysis, and you can only use this command once after ST setting your data. So you've told Stata, this is survival data. So streg knows, hey, I'm working with survival data right here. So it knows that the event is the outcome the outcome. So event is the y variable or the outcome, and time is a key covariate. So it already has time in the background and knows that it's like dealing with time. So what it does is it calculates hazards ratio here, which describes the instantaneous risk of something happening given the event hasn't happened yet. So it's kind of a conditional probability in each individual time interval. So this is the risk of giving birth in a given month. Remember our analysis time. Oh, actually, I think it's in years in this case. So it's the risk of giving birth in a given year on the condition that a birth hasn't happened yet. So our regression here tells us a few things about what's associated with a higher hazard of giving birth. So for example, like we saw in the Kaplan-Meier plot, the less educated people had a higher first birth hazard compared with more educated people. So the highly educated are the reference group here, and the less educated it's a 1.62 to 1 hazard ratio, and it's significant. So it's as expected. There's the low educated people have a hazard ratio of 1.62 in reference to highly educated people of having that first birth. People who have more siblings. So in our example, we did this regression has education, number of siblings, and the year you were born. And people who have more siblings, so siblings is continuous. If you have one more sibling, for each additional sibling you have, your hazard ratio is 1.0. You're 3% more likely to have a first birth in any given interval. And then being born more recently, so having a higher year of birth, so basically being younger, decreases the hazard of first birth, which also makes sense because the older you are, the more likely you will have had a first birth. So that's a quick tour of some key and fundamental analysis that you can do using the Harmonized Histories and how to use the survival analysis commands in Stata to do that.